Today I'm going to explain about design and implementation of H-slot microstrip patch antenna, which we have designed it in my major project. This microstrip patch antenna has very wide useful in many areas like electronics and communication techniques. It is majorly used in mobile phones and personal computers. It has many advantages, and the problem statement is the antenna has a reflection coefficient of minus 25.55 dB and VSWR voltage standing wave ratio of 1.11 at a frequency of 4.8 GHz. In this antenna, the gain is fairly moderate and the cross pollution is high. Microstrip patch antenna is very low profile and it is conformal to planar and non-planar surfaces. It is also very simple structure and it is very cheap to manufacture using modern technology. It is mechanically robust when we adjust it to any other rigid surfaces. Here the yellow strip is called microstrip and the gray part is called substrate part and the below yellow part is called ground. Microstrip patch antenna consists of three layers. First one is microstrip and substrate and ground. Ground and microstrip are metals, generally like copper and etc. metals. Substrate is used some special type permeability, which are some of them are FR4 and epoxy substrates. Working of MPA. The main principle of microstrip antenna can be demonstrated by method of analysis. There are many methods of analysis like cavity model and other methods, and we used the cavity model because it is easier to explain and gives more accuracy than others. Equations. The slot dimensions can be calculated by these equations. L effective is equals to L plus change in length and so on. These equations can give us the dimensions of the required patch antenna. Fringing fields. The dimensions of the patch are very finite. The fields at the edge of the patch undergo fringing due to the change in dimensions of the patch when we energize the microstrip patch antenna. The amount of fringing is usually related to the height of the substrate. We have used CST Microwave Studio 2019 V as a software to design this microstrip patch antenna. In the first phase, we have attached the microstrip to a ground plane without any slot on the patch. We observed the S11 minus 31.32 decibel at a frequency of 5.66, which is very high and not suitable. So we have introduced a rectangular slot, which then yields S11 ratio of minus 16.45 dB at a frequency of 5.55 GHz, which is usually better than the previous one. And then we have finally designed the H-slot microstrip patch antenna, which is the final phase. And we can see there is a side view and top view of the microstrip patch antenna. This is the 3D representation of a H-slot microstrip patch antenna. And we have calculated the polar plot of radiation pattern in the far field using the CST. Here the diagrams depict the polar plot of radiation pattern. S11 parameter of H-slot microstrip patch antenna, which is the S11 ratio, which is 4.6 GHz at which is nearer to 0 at 4.6 GHz, which is very good. We can see the difference between our result paper and paper result. We have improved S11 and gain and resonant frequency and bandwidth also. But we want to introduce the slot with a very different type of shape so that we can achieve a greater result. So this is one of the changes. Here the G is the rectangular slot between two curved C slots in between them. So by varying the length and width of the G can give us various results like shown as mentioned in side figure. At the same time, we also calculated the parametric differences of the breadth of SW as mentioned in the figure, and we can by varying various distances we have achieved various S1 ratio, and we choose which one is greater and better for the microstrip patch antenna. In the same way we have analyzed the parametrics of SH and SL also. And here is the operated microstrip patch antenna, which gives the S11 ratio of minus 15.83 dB at a frequency of 8.76 GHz, which is very good and useful for many other applications. And we have taken the polar plot of microstrip patch antenna at 8.76 GHz using CST, and this is the diagram of polar plot. Final model of the microstrip patch antenna in 3D model and simpler model. And we have also designed the array of this microstrip patch antenna because to increase the gain and reduce the cross polarization of the antenna. By designing the array, we have increased the gain to 14.81 dBi and cross polarization to minus 12.4 dBi, which is very good than the previous one. And axial ratio of electric field at pi is equal 0 and theta is equal 0 can be calculated as straight line, which implements that whether it is circularly polarized, electrically polarized or linearly polarized. By observing the axial ratio field, we can say it is clearly linearly polarized. Here are the previous results and updated results, and by checking the difference between them we can see that the array can be very useful than the singular microstrip patch antenna, but due to various applications we can use either array or single microstrip patch antenna according to its use. Dimensions of the microstrip patch antenna are given in the table as follows. And concluding with the point that stable microstrip patch antenna is used to improve the parameters of antenna like bandwidth and gain. This designed antenna is as acceptable gain and directivity and voltage standing wave ratio. Array is built using 4 MPa or greater, but we have designed it with 4 MPa to further increase the gain. Future scope: the further reduction in cross polarization can be done in many ways, but we have stopped here due to our project deadlines, and so but we can reduce the cross polarization more than enough. Enhancing the gain: we can enhance the gain by taking more array structures, and we can also further reduction in angular width, and we can achieve frequency or bandwidth configuration. And thank you.